Welcome to the next in the StrainSense Devotron how-to video series. In today's video we'll show how to record three-phase power synchronized with GPS time. A typical application is for renewable energy three-phase power measurement, including wind farms and solar farms with inverted three-phase output that need to be recorded in sync with GPS time for correlation with other grid data. Here we'll show the equipment that was required for this application. Here we have a DEVI2A4L data acquisition unit with 1 terabyte storage drive, gigabit LAN interface for network connection if required, and built-in display for real-time and post-processing of data on board. Here we have a Trion power module with 4 high voltage and current sensor inputs, either with voltage or current output. We have a Rogowski coiled current sensor for AC current measurement, and we have a high accuracy GPS receiver. Next we'll look at the data channels set up in the oxygen acquisition software for this application. First we'll look at the Trion timing module. Here we have enabled the GPS input and we'll then use the GPS signal for the time sync later on in the setup. We also have digital inputs available in the timing module that can be used for event triggers or event markers. Next we'll look at the Trion power module. We configure 3 high voltage inputs that are in the range plus or minus 2 kV and 3 current sensor inputs with a voltage input and scaling to current. We also have a additional high voltage and additional current sensor input that can be used for a DC power measurement upstream of the inverted output if required for total efficiency measurement. Next we'll look at the three-phase power grid setup. Here we see the three-phase power grid setup with 3 high voltage and current sensor pairs. In our settings we can see the sync source for the power group is the first voltage waveform. Harmonics have been configured in the power group, and by default the maximum harmonic order is 50. This can be set up to 1000 if required. There is also the option for a mechanical power analysis using a speed and torque input, and this is particularly relevant in the case of a wind turbine with shaft input to the generator. This can then be used to calculate efficiency from mechanical to electrical across the generator. We can also generate an efficiency map using that data within the oxygen software. Let's now look at the output from the three-phase power group. We can see here the key power parameters that are published from the power group. Let's now look in the active power group. We can see that for total active power it's available on each phase and in total. We can also break that down into the fundamental and the harmonic content. All power data is available at the detected fundamental frequency of the system, and that data can be recorded and both used for display purposes. Let's now look at the sync setup of the system. By default, the oxygen software configures the acquisition unit with auto setup using its internal clock. We need to disable that and enable the GPS input for sync, and we can see that we get an indication here of GPS locked sync in the top right hand corner. We can also use other timestamps including IRIG, PPS and PTP depending on the application. Let's now look at the recording mode of the system. Here we can see by default the system is configured in a continuous recording mode. We can also configure event-based recording, where we would use a defined event either from an input channel or using input time to record for either continuously or a fixed period of time, both before and after the trigger. The system is now ready to record data. On the manual toolbar, we can see manual recording can be configured simply by clicking the record button, and data will start to be recorded. Let's now look at data that's available with the system. Here we see our power meter that shows for each phase and in total key power parameters, both for the total power group and in the fundamental. We also have digital meters and analog meters that are available, and these can be configured for the colour range required depending on the display requirements. Next, we'll look at our phasor diagram. This shows us the voltage, current and active power on each phase and the phase angle between the voltage and the current on each phase. Finally, we have the harmonics chart. This shows us the harmonic content up to the order that we've defined in the power group and the interharmonics, in this case up to the 50th order. This is both the voltage and current displayed in a logarithmic scaling, and it's published separately for each phase. We can also record the raw waveform of the voltage and current on the input to the power module. Here we can see voltage and current data for a 3-phase 50 Hz system, and this can be analysed in more detail, particularly in the event of any events of interest on the network. We can also export the waveform data and any other data directly as a PDF report from the Oxygen software. That summarises the setup of the DEVI2 system and Oxygen software for a renewable energy 3-phase power measurement synchronised with GPS time. For further information about this application, please get in contact with StrainSense via the contact details on the website. We look forward to being in contact with you soon.